So in the previous video, we talked about normal covalent compound bonding. Now we're going to talk about some of the exceptions. So beryllium chloride is BeCl2. Go ahead and pause the video and figure out your valence electrons and who will go in the middle, and then restart. So chlorine came in with 7. 7 times 2 is 14, and beryllium came in with 2. So that gives us 16 valence electrons. Beryllium should be in the middle, with chlorines coming off. Beryllium came in with 2. So beryllium at most is generally going to get 4 electrons. It currently has 4. So we're going to ignore beryllium. So yesterday, or on the previous video, we said in step 6, make sure that every atom has 8 electrons unless it's boron or beryllium. So this chlorine needs 6. This chlorine needs 6. We have 12 left. So this is our Lewis structure for beryllium chloride. Arsenic pentabromide is AsBr5. Go to calculate your valence electrons and restart your video. So you should have gotten 40 valence electrons. Arsenic's going to go in the middle, but there's 5 bromines. All 5 bromines will come off of the arsenic. So 5 times 2, we need to subtract 10 out. Anything from the 3rd energy level down, all of these can have more than 8 electrons. They don't want more than 8, but they can have more than 8. They have an expanded octet. Again, this is rule 6. So the only ones that can't are these right here. They can get an expanded octet because they're going to put those empty electrons in their empty D. So arsenic is more than fine because it currently has 10 electrons. But each bromine needs 6 more. 6 times 5 is 30. We have 30, so it should work out perfectly. So this is arsenic pentabromide. So don't freak out if you have 5 things coming off of bromine. But at the same instance, if you ever have something that looks like this, that's going to be incorrect. You're never going to have a double or triple bond if you have an expanded octet. Go ahead and pause the video and try Bi3 on your own. Restart when you have your answer. So you should have had 24 valence electrons. Boron should have been in the middle. You have 18 left. Boron was our other exception. Boron generally only gets 6 electrons, double what it came in with. So it currently has 6, so we're going to ignore boron. Any other element besides boron or beryllium, you would have to make sure that it has 8. So pay good attention to that central atom. But each of my iodine only needs 6. 6 times 3 is 18, so I have the perfect amount to satisfy all my iodine. This one, C2H6, is a little weird. For your valence electrons, you have 4 times 2, and then 6. So you have 14 to work with. So I couldn't have this as the structure because carbon has way too many things coming off of it. It's not one of the ones we highlighted here, so there's no way carbon can have more than 4 lines or 4 bonds. So when you have a hydrocarbon like this, you're going to have your 2 carbons in the middle, or however many, and then since we have 6 hydrogens, just put 6 on each of them. So we've drawn 2, 4, 6, 8, 10, 12, 14. And at this point, each of our hydrogens just have a line, so they're good. And each of the carbons have 8 valence electrons, or 8 electrons, so they're good. So this last one, go ahead and pause the video, get your valence electrons, figure out your central atom, and draw the structure. Restart when you have your answer. So this one you had 42 electrons to work with. Br should have been in the middle with 5 fluorines coming off. So minus 10, you have 32 left. Boron is good, or bromine is good because it's got at least 8 electrons. Each of your fluorine currently have 2, so they need 6 more. So we have at least 30 electrons, so we're going to add all of those. But in this case, I have extra electrons. Do not double or triple bond if you have extra electrons. Extra electrons go on central atom. So bromine currently has 2, 4, 6, 8, 10, but it can hold those extra ones. So that is your final structure for BrF5.